Hello all, today's video is regarding the container manager demo for version 0.1.0. Now in the previous video we have already discussed with respect to the reason for having a specific tool for our automotive use cases, especially in software defined vehicle, and today we'll be getting in depth with respect to what this tool is all about. Okay, so you can check this particular PPT. It will be attached in this particular video's description. You can get the link of the repo as well from here. So this is the code structure of this particular project. So you will have the actual tool, which is the container manager under the app folder. There is a configuration folder, there is a storage folder, and there is a post analysis folder. Now under this particular application folder, this is the runtime subfolder, container runtime subfolder, where we can add whatever container runtime we want and whatever C group configuration we want as per our requirement. So as of now, for this particular 0.1.0 version, I am having Docker as a container runtime, and I am having the C group version as v1. Going forward, I would like to add Podman also as another container runtime, and I would like to support even for C group v2 as well. And coming to the database, here we are speaking with respect to time series data. So it is better we have a proper database. So as of now, I am using SQLite because it is much smaller in size and will suit for this particular requirement whichever I have. I have created a database interface, so you can swap this particular SQLite with any other database, whatever you want. So proper design patterns and everything have been followed in this particular while creating this particular code base. So with respect to plugging and swapping any of the tools as per your requirement should not be a problem. It should be very easy. And coming to the metric analyzer, so this is where the collection of all the metrics will happen. So as of now, I am supporting the total CPU, total memory, and the total PIDs for each container. So this is what I am supporting as of now. But even in CPUs, with respect to C groups, there are multiple ways of basically doing the same thing with respect to CPU shares, or with respect to CPU per core or CPU per host. So many things are there. As of now, it is general CPU per core is what I am doing as of now. And the UI, basically what I used is the Ncurses UI, which is extremely lightweight and dashboard friendly. I mean, like terminal friendly. So that is the reason why I had this, because we are speaking with respect to an automotive device. So there is no browser, nothing over here. So ideally you will basically be working from terminal. So Ncurses has been selected with respect to keeping that in mind only. And this is where we have the fundamental logic. We have the thread pool where multiple threads can be created, and we can basically tune how many containers we want to monitor per thread. So I will explain you anyways regarding that going forward. This is the config folder where we have a as of now a tcontainer UI for creation of the parameter.conf. So this is the configuration file using which we can actually tune the sample rate, how many threads we want, and how many containers per thread we want, and what should be the UI refresh rate, what should be the container sampling rate, etc. So everything can be controlled from here, which will be generated from this particular UI. Storage is where once the application stops, it saves the container metric as .csv file, it exports it. Similarly, during this entire time while the container is running, the host usage is also saved as .csv. That will also be saved in. And apart from this, the entire metrics will be saved as a .db files for any other future analysis if at all it is needed. And this particular post analysis folder has the post analysis tool which is based on matplot and tkinter, and it basically extracts the data from these exported CSVs, and it creates a chart for us to interact with the graph and kind of analyze how things are working. So this is the code structure. Coming to the deployment diagram, so this is how it is. So this is our ECU or HPC or whatever it is. So this is that section. The container runtime will anyways be part of this particular ECU only or HPC, but for the sake of description it has been kept outside. And this is where the person whoever handles it basically can create the configuration file and send it into this particular folder, or he can basically use these dashboards for post analysis. And we have the database in the HPC or EC, whatever it is. So this is where it is. So we have the main application, we have the container runtime module, we have the utils for general utilities functions, we have the monitoring services, incursus, all these dashboards and all. And this is the underlying Linux C groups and the v1 and v2, where we basically do the kernel calls for getting the information of the CPU memory and PIDs directly, rather than relying on any other APIs to make things much more faster. This is the background. Now, this is the first UI, which is the parameter, how we fix the parameters. So we can basically select the runtime whichever we want, C group whichever we want, database as of now it is only SQLite, and the other refresh intervals where we want to save the DB path and the export path, all these things. So once we have this particular selection done, we can click on export, and based on that particular export the particular files will be created. Anyways, during the demo you will get to know how things work. And once the application starts, it basically spawns a few threads. So the first thread is basically the event listener, the second thread is the event processor, and there is a resource monitoring thread and a resource thread pool thread. So you have 4 threads. So the event listener thread, the job of this particular thread is to look for any change of events which are happening with respect to the underlying container runtime. Like say the underlying container runtime is Docker, and say an application or a container is started. Say it says that somebody starts a particular application inside the HPC. Okay. Now this particular event listener tracks this particular events, and it kinds of records this particular creation of this particular container along with the name, the container ID, and the state of the particular container, like whether it is started, stopped, created, whatever it is, and it saves it in the database. Now this is a separate thread. The event processor, what it does is and another thing, once the event listener basically gets these events, it pushes the particular event into a queue, an event queue, which is basically thread safe queue, which is monitored by the event processor thread, where once a event queue has a content inside it, the event processor basically pops the event and tries to make sense out of it, and it basically maintains a list of all the containers which are active, which has to be monitored. Now this information is basically shared to the resource monitoring thread, where it basically polls the containers which are running, and at the same time it basically polls the host machine's CPU and memory as well. Okay. And once there is any particular container, then this particular information is shared to the resource thread pool. In the resource thread pool, basically you can select how many threads you want in this particular pool. Say you select the thread pool size as 5, so you have 5 threads running, and say there are 3 containers running, then one container will be assigned per thread. Now the job of this thread is to individually target and get the data from the underlying folders wherever these particular data are saved, and there is something called as batch. So instead of inserting each and every reading into the database, basically what I'm doing over here is I'm collecting a batch of data, like 20 samples of container 1, 20 samples of container 2, and only when the batch has reached the limit of 20, it does an insertion. Say while it is yet to reach the 20 limit, and say for some reason the container has been stopped in between, say it has collected say some 14 samples, and for some reason container has been stopped, then the insertion for the exact 14 ratings will also be done. So there is no wastage of means the data is not skipped. That's the basic idea. Okay, as we have multiple threads, the work is very fast, and once this particular threads basically push the data into batches, and per batch it tries to get the maximum of, like say for container 1, 20 samples have been collected, and out of these 20 samples the maximum CPU value was say 98, and the maximum memory which was consumed with respect to how much it was allocated was say somewhere around 70%, and the maximum PIDs, like PIDs 100 PIDs were allocated and it is running 100 PIDs for some reason, then it is 100%. So it takes the maximum of all of these and it pushes into the message queue. Because when when a user basically is trying to monitor it, visualize it while doing the debugging live, then it is very tough for him to process data which is coming at a sample rate of say some 50 milliseconds. You cannot visualize what is going on. So what I'm doing over here is I'm collecting a data across 20 samples in the sense, like you have 50 millisecond per container and you have 20 samples of it, means in 1 second. So in that 1 second, basically what I'm trying to do is what was the maximum CPU, maximum memory and maximum PID of that particular container. Now say the maximum CPU and maximum memory were below the threshold limits, and the maximum PID has beyond the threshold limits or touch the max or cross the max, then we can specifically focus on only on that. So it will be easy for us to debug. Means it's not like debug, but at least while you are creating the test cases and all, it will be easy for you because you are seeing it live. That is the main idea behind it. And in the parameters also we can basically enable or disable the UI. So that's the reason why we have plotted it in a dotted way. So you can, it's an optional thing, you can have it or you need not have it, that's up to you. So this is the Ncurses UI which I was talking about. So here you can see that this particular stress application is consuming CPU resources more than 100%. So what I mean to say is, when this particular stress test application, so stress test is nothing but it's a Docker image which was created by me especially for this particular project. So you can I will give you the access for, yeah, it is available in Docker Hub for anyone to download. So here when this container was spawned, I allocated only one CPU for it. But when the stress application is running, I have forced this particular stress application to consume 4 CPU cores. So what is happening over here is, so this stress test, it is consuming the CPU more than 100% once in a while in this particular batch of 20. So that is what is reflecting over here. Similarly, the maximum memory which this particular stress test application is consuming is below the limit of what I have provided. So I think I have allocated somewhere around 512 MB for this particular stress test application to consume, but it is consuming way less than that, somewhere around some 200 MB or what is being consumed. So that is what is reflecting over here. And in this particular stress test application, I think the maximum PIDs while I was creating, I restricted it to somewhere around 30 or 40, and in the application I am forcing for 100 PIDs. So because of which it has reached its maximum limit, and it is exactly at 100. So while a person is analyzing this, so he knows that for this particular stress test application, he need not focus on the memory part. So it you will not have any issues with respect to that. And with respect to PIDs, you can see that it is reaching exactly 100%. So whatever has been allocated has been consumed, and it is not shooting up. So the possibility of having any issue over here is also not there. And when it comes to CPU, there are continuous spikes at least once, because we are only taking the max value over here, not the average of it. So for this particular application, we have to focus on the CPU. And coming to the other application, RabbitMQ, it is green all the time, especially only when it starts for the very first time, there is a momentary spike. Apart from that, everything is fine, everything is under control. Similarly, for stress test 1, this is another container of the same. So here also we can basically see that even the PID is also below the limit. From a user point of view, how easy it is for him to debug. So keeping that in mind, I am considering only the max value. And this is the post analysis sheet. So once the tests everything are done, so this is the UI where you can basically select what application you want, what application you don't want, means what container you want, what container you don't want, and you can basically see the live readings of it while you hover over the particular plot. You hover anywhere, you will get the CPU, memory, and PID of that particular container or multiple containers. You can basically zoom in, zoom out of the containers, and you can just have a much more detailed analysis. Okay, now it's time for us to get into the demo, but before we get into the demo, I will show you the repository as well. So this is the repository. I will attach the link in the description, where you can everything which I am speaking is already out here, as explaining with respect to UI, everything, the Ncurses dashboard and everything else over here. And I have created a Doxygen based documentation for this project for anyone to basically access it and to easily understand it. Okay, so before we get into that, so let us start with respect to the configuration. So this is the config file. So let me just keep it always on top. Let me go to configuration. Let me say the thread capacity. Let me have the threads as say 5. Let me have the thread capacity as 2 or whatever it is. If at all I create, click on create, then this particular parameter.conf will be updated. So it is only to make sure that people don't change any value by mistake. So this is with respect to that. And now there are two modes of building it. One is a debug mode, one is a release mode. Let me just build it in the release mode first. So I am building the application in release mode. So I will just show you the application is 300 KB in size, so very light application. Now let's run the application. Okay, now before we run the application, I would like to show you the database also. So this is the SQLite web interface. So there are no tables created. Now let me run the container, and let me try to have the Docker stats also. So Docker stats is running in background, and let me hit this. So the So there are no containers, so that is what this application is showing. Earlier there were no tables, so now if at all I refresh, you can see that there are 3 tables created. One is the container metrics, so there are no containers, so there are no metrics, and the list of containers, there are no containers running, so nothing is over here. And this is the host usage. So host usage, so this is the host machine resources which are being consumed as of now, as we speak. So what I do right now is let me run this particular application. So I am running this particular stress tool. I have allocated 1 GB of memory. I have allocated 3 CPU cores, and the name of the application is stress1. So let me hit an enter. Okay. So now that this application is running, so let us go over here, the containers. If at all I go to the content, so now the stress1 application is up. This is the ID. This is the CPU memory and PID limits of this particular application. So the PID limit is 30. Okay, and the container metric of this particular application, it is if at all you can see, it is refreshing at 100 millisecond in this particular example. Okay, now let me come back to the UI. So as you can see, this is the live UI and this is the Docker based UI, Docker stats. So out of the 3 CPU cores, how much is being consumed? All the 3 are being consumed, and there is an overshoot also. That is what it is showing. With respect to memory, 1 GB was allocated and it is consuming only close to somewhere around 200 or whatever. So it is like 20 to 30%. So that is what is being shown over here. And with respect to PIDs, 15 PIDs are being consumed, and we have provided the resource allocation as 30. Okay, so it is 50% PID. Okay, that is what this particular application is. Now let me run another application. So this is RabbitMQ, 1 CPU core, 512 MB, and and the PID limit is 100. So let me hit an enter. So the second application will be up and running. So the second application is up, RabbitMQ is up. So this is the second application, RabbitMQ. And now let me do another thing. So let me run this third application. Okay, so the main idea why we have this tool is so these are the 3 applications. These are the container metrics. These are the insertions which are happening. So we have insertion with respect to stress test, we have insertion with respect to RabbitMQ, and we have insertion with respect to stress test 1 also. So we have all 3 containers, 10 milliseconds each, 100 milliseconds gap each, and you can see that there will be like same timestamps will be appearing in both these containers, because we are actually running 5 threads. So each of the container is allocated per thread. So parallel processing is happening everywhere. Okay, now the advantage or the reason why we have this particular tool in the first place is because of this tool I can basically visualize it. Okay, unlike even Docker stats is also doing the same thing, but I know that in the background the data is sampled at a very high rate and the rate at which I want, which I can modify from here. And at the same time I can basically create some kind of alert warning. Say anything above 80, it is basically an alert, so the color of the marking of the numbers change into yellow, and anything above 100 is red. So I can quickly get into this and I can quickly concentrate on this while I'm doing a live debugging session. So these are some of the advantages, and exporting the data, that is another thing. Okay, so now let me do one thing. Now let me stop these containers one after other. Let me just keep it on top. Let me stop the stress test application. The application is removed. Now let me remove the RabbitMQ application also. So you can just see the response time also on how quickly this gets gone. So it refreshes only when the 20 samples are done. So because we are showing the max value, and it depends even on the UI refresh rate as well. Okay, now let me remove the stress test 1 also. Okay, so I am removing all these 3 applications. Now all the 3 applications are gone. Now that the applications are gone, I will do one thing. I will just hit a Control C over here. So when I do a Control C, all the containers are removed and the export has been done. Export of the files. So I should have shown you the files earlier, but anyways, so these are the files which are basically exported once we hit a Control C. Okay. Now let's get into the analysis part. Okay. So now that we have the files with us, what I will do is I'll get into post analysis. I will now, so this is the application. Okay, so what we are trying to do over here is we have created this particular plot out of the two CSVs which have been exported. Okay, so let me just zoom out. So if I hover, you can see the RabbitMQ, the legend where you can see the RabbitMQ, this test and this test one over here, and at the bottom you can basically see the CPU over here. Yeah, it will be there as long as I am over here, but this is the place we have to focus. So while I move the mouse over the plot, you can basically see the host CPU, host memory consumptions with respect to percentage, and the consumptions of this particular containers individually. Okay, now say I want to specifically focus only on stress test 1 application, so I can just untick these two. So right now we have only the host machine and the stress test details only, and I want to kind of do a fine analysis. So let me just zoom into the plot and let me just move to the plot to the area of my interest. So let me just hover over here. Yeah, so this is the spot where the stress test 1 application has started. So earlier the CPU was only 57, and this is the point where the application stress test 1 has started. So over here the CPU consumption of this particular host machine is somewhere around 50%, but when it started, then it shot to 70%, and it consistently stays over there, and sometimes the host machine entire CPU utilization reaches almost 90%. Okay, so you can basically zoom in, you can zoom out, you can, and say I don't want to have this particular host usage. I'm not interested, so I'll just click on here. The host usage is gone, so let me focus only on stress test and the RabbitMQ applications. So these are the two applications which we are interested on. Let me just zoom out. So yeah, so basically you can do whatever you want. You have a lot of flexibility with respect to this particular thing, and say you're done with it, you just simply click on quit, and yeah, you will be done. Okay, so this is the demo, and there are a lot of things which have to be added over here, with respect to having much more finer sampling rate. I have not tested this particular system extensively. I would like to have somewhere around some 40 or 50 containers running in parallel, and seeing how they perform. Lot of testing I have to do, but as this is the first version, I just want to showcase the concept of this particular container monitoring tool, why it exists, what are the shortcomings of the existing tools which are out there, which will not actually completely fit our requirement, and why this tool tries to address most of the shortcomings of the popular tools which are out there, which are extremely good, which are really great, and it has a great community behind. But the problem over here is that doesn't suit our requirement. So yeah, that is with respect to this particular container container monitoring tool, and this is my demo. Thank you all. Thank you for your time. Have a nice day.